Hello everyone, welcome to Mastermind. Today let us solve 5 problems based on permutations and combinations. If you have watched the theory video provided earlier on Mastermind based on the permutations and combination, this video will be a lot easier for you to understand the concept. So let us look at the first question. In how many ways can the letters of the word messy be arranged? If you have watched the earlier video, you will get to know that in order to solve such a question, the formula is n factorial divided by p1 factorial, p2 factorial up to pr factorial. So if we consider the word messy, when we consider the word messy, there are totally 5 letters here. Therefore, n equals 5. And the word messy has 1 m, 1 E, 2 S and 1 I. Therefore, in how many ways can the letters of the word messy be arranged can be solved by using this formula. Therefore, the required number of ways will become 5 factorial divided by 1 factorial into 1 factorial into 2 factorial into 1 factorial. 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. 1 factorial is 1, 1 factorial is 1, 2 factorial is 2 and 1 factorial is 1. So the numerator is 120 divided by denominator is 2. Therefore, this comes out to be 60. Therefore, the word messy containing 5 letters can be arranged in 60 different ways. Therefore, the right answer over here is option C, 60. Now, the second question says, in how many ways can the letters of the word leader be arranged? So, first of all, let us see how many letters that the word leader contain. So, the word leader contains 6 letters. So, hence n equals 6 here. And it contains 1 L. It contains 1 L, 2 E, 1 A, 1 D and 1 R. So the word leader contains 1 L, 2 E, 1 A, 1 D and 1 R. So the required number of ways will be calculated by using the earlier formula itself, that is n factorial divided by p1 factorial into p2 factorial up to pr factorial. So here n factorial means 6 factorial divided by 1 factorial into 2 factorial into 1 factorial into 1 factorial into 1 factorial. So when this particular thing is taken into consideration, when we solve this particular equation, we will get numerator as 720 because 6 factorial is nothing but 720 and 1 factorial is 1, 2 factorial is 2, 1 factorial is 1, 1 factorial is 1, 1 factorial is 1. Therefore, numerator will be 720 here and denominator will be 2. Therefore, it comes out to be 360. So, the word leader can be arranged in 360 different ways. Here, the right option is option C, 360. Now, consider the third question. In how many different ways can the letters of the word optical be arranged so that the vowels always come together? Now, let us consider the word optical. Word optical, O-P-T-I-C-A-L. There are 7 letters here. Therefore, we can write n equals 7. And the condition is that the vowels should always be together. Here, the vowels are O, I and A. So, we will write it down. P, T, C, L are not vowels. They are consonants, while O, I, A are vowel. So now we have to form or arrange the words such that the vowels are always together. So we'll have to take this as one combination, or it has to be considered as one letter. It should be supposed to form one letter as per the condition now. Therefore, we have got 1, 2, 3, 4, 5. So there can be, we have to consider this as arranging 5 letters, 5 different letters. So according to the condition given and applying the condition to the letter optical, we have to arrange this as 5 letters. Therefore, now this 5 letters can be arranged in such a way that it is nothing but 5p5. That is, we have to take Since the vowels should always be together, OIA is considered to be, or it is assumed to be, one letter now. Therefore, we have to arrange the entire combination as 5 letters taken 5 at a time now. So we know that NPN is nothing but n factorial. So 5p5 should be equal to 5 factorial. 5 factorial is 5 into 4 into 3 into 2 into 1, which is nothing but 120. However, it is not possible to limit the problem here itself. The next thing is, even OIA can be arranged like OIA, IAO, OAI, etc. So even that combination should be taken into consideration. So here what happens is, these three letters should be taken or should get arranged taking three at a time. Therefore, what happens is, taking three letters at a time from the combination of three letters OIA, that means we have to take 3p3, which is nothing but 3 factorial, which is equal to 3 into 2 into 1, which is nothing but 6. So PTCL and OIA as a combination can be arranged in 120 ways, while OIA itself taken together can be arranged in 6 ways. Therefore, now what happens is, we have to multiply. Required number of ways becomes multiplying these two ways. The entire letter of word optical as one combination and OIA together as a separate combination. When we multiply 120 into 6, we get 720 as the answer. Therefore, in 720 different ways, the word optical can be arranged so that the vowels always come together. Therefore, here the right option is option B, 720. Now, fourth question says, in how many different ways can the letters of the word leading be arranged in such a way that the vowels always come together? This is like the last question itself. These are a bit tricky questions, so we have to solve it more to understand it better. Here, let us consider the word leading, L-E-A-D-I-N-G. It has got 7 letters. So let us say it has got 7 letters, and the vowels should always be together. The vowels over here is E, A and I. So now let us rearrange it. L, D, N, G are consonants, and we have to arrange the letter in such a way that E, A, I are always together. So now when we consider this particular point again, we have got 5 letters. We have to consider again E, A, I as one combination because they should always be together. Therefore, again we have to consider this as 1, 2, 3, 4, 5. 5 letters taken 5 at a time. That means 5p5. We know that npn is nothing but n factorial. Therefore, 5p5 is nothing but 5 factorial, which is equal to 5 into 4 into 3 into 2 into 1, which is 120. And again, the problem is not over here itself. We have to see how EAI can be arranged amongst itself. How EAI taken 3 at a time gets arranged. EAI can be arranged as AEI, IEA. So the condition is that vowel should be together, but the order has not been specified, like it has to begin with I or end with A or end with E. So any combination is possible over here. Any kind of arrangement is possible over here. Therefore, here we have to consider the arrangement within the set of vowels itself. Therefore, we have to arrange it in such a way that 3 letters taken 3 at a time out of 3 words EAI. Therefore, this becomes 3p3, that is 3 words taken 3 at a time, which is nothing but 3 factorial, which is equal to 3 into 2 into 1, which is equal to 6. Therefore, here we can say that the required number of ways will be obtained only after we multiply both the arrangements. So both the number of ways. Here it comes down to 120 into 6, which is equal to 720. Therefore, the word leading can be arranged in 720 different ways in such a way that the vowels E, A, I are always together. Therefore, the right option over here is option C, 720. Now, let us look at the last question for the day. In how many different ways can the letters of the word detail be arranged in such a way that the vowels occupy only the odd positions? This is more trickier. So let us solve this. Let us consider the word detail, D E, T, A, I, L. So there are 6 letters here, and the condition is that the vowel should occupy only the odd positions. Let us break it down. So if we consider this 1, 2, 3, 4, 5. Let us say 1, 2, 3, 4, 5, 6. The condition here is that the vowels, which are the vowels here, E, A, I. So there are 3 vowels here, and which are the consonants over here? There are 3 consonants. They are D, T, L. So these are the 3 consonants here. The condition is that the vowels should occupy only odd position. That means this combination EAI should occupy 1, 3 or 5th position, while DTL should occupy only even position. In other words, it should occupy 2, 4, 6. So when we take up this particular condition in the problem, we will get to know that the 3 vowels EAI should be occupying only 1, 3, 5. So that means 3 letters taken at a time to place among the 3 odd positions from the group of 3 letters. So that means this is nothing but 3P3, that is 3 letters or 3 vowels EAI taken to fill the 3 positions 1, 3 and 5. Therefore we know that NPN, this is a standard formula, you'll have to remember, NPN equals N factorial. Therefore 3P3 means 3 factorial, which is equal to 3 into 2 into 1, which is nothing but 6. The other condition that comes naturally after satisfying this condition is that DTL should occupy the even position. This comes naturally after satisfying the first condition. So now again 3 letters DTL should be taken 3 at a time to fill the even places, which are 3 in number, that is 2, 4 as well as 6. Therefore again the combination is 3 letters, 3 consonants DTL taken 3 at a time to fill 3 places. Therefore 3P3 equals 3 factorial, which is nothing but 3 into 2 into 1, which is 6. So the problem is not over here itself. Now what we have to do is, there are 6 ways in which vowels could be arranged only occupying the odd positions, and there are 6 ways in which the consonants could be made to occupy only the even positions. So now we'll have to multiply both the ways to arrive at the total number of ways in which we can arrange the word detail so that only the vowels occupy only the odd positions. Therefore we will multiply 6 into 6. Therefore the final answer is going to be 36. So in 36 different ways the word detail can be arranged so that the vowels occupy only the odd position. Here the right option is option C, 36. So this is all about permutations and combinations in this video. Please try to solve more problems of this kind on permutations and combinations. Thank you.